The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Being Dodger Stadium, it is a talk developed by Janet Marie Smith, who is Vice President of the Dodgers in the facilities area. And then the co-speaker and co-author is Ryan Wilkerson, who is a principal with Nabin Yousset Associates, structural engineers in Los Angeles. So unfortunately, or fortunately, because the Dodgers are doing so well, Ms. Smith is unable to be with us as she's traveling with the team as they continue their playoff run in Chicago. But fortunately, we do have Ryan here to talk about Dodger Stadium for us. So thank you.
Yes, thank you. So good morning. It's too bad that Janet Marie couldn't be here, but at the end of the day, what they do is about putting a baseball team on the field, and so she needed to travel with the team to go see how they were going to do in Chicago. We would say fortunately. I think some other people in the audience may say unfortunately. They're continuing their run. I've already spoken to a few of them this morning, but I'm hoping they come out victorious. So good morning. This is kind of a little bit of a different spin on the preservation talk that we just heard a little bit about, which was kind of in that vein of restoration side of things. This is kind of more about a preservation work that is done through maintaining relevance. It's really not letting the facility get to the point of degradation that needs to do a lot of the preservation work. So really what we're talking about here is preservation through relevance. And I was hoping that, Janet Marie was supposed to be here with me today to give you kind of the aesthetic, architectural vision, coupled with the structural vision of safety and stability. So as she's not here, I'll try to do my best to put the architect hat on. I'm not always the best at that, but I've got a few notes from her. To start with, she wanted to make it very clear that the Dodgers are extremely proud to have really the only mid-century modern MLB stadium in the country. And they really celebrate this, and they protect it ferociously. It was built at a time when baseball was largely building parks that were multi-purpose parks. They were very large. There was a football team, there was a baseball team. This was one of the parks that was built for strictly baseball use. And it was also a very large park. So it has maintained that relevance, and it's one of the last parks of this size. In fact, it is the largest park in the major leagues right now by a pretty significant margin, built in an area when these larger parks that were actually built as multi-purpose venues started to close. So they're very proud of the fact of maintaining that. So maybe, since it is baseball, a little stats just to get us started. It was opened in 1962. It was owned by Walter O'Malley. He built it when the team moved from Brooklyn, if you didn't already know that. It took about 3 years to build, about $23 million at the time, a mere $182 million in today's dollars. That's clearly a bargain, I think we would all say, from the stadiums we see built now. The architect was Captain Emil Praeger. He was a captain. He was also a civil engineer. You can see in the design of the stadium and even the documentation of how to build the stadium, the civil engineer side of him really shone through, as you'll see in a few slides. He was also actually the designer for Shea Stadium, which is one of these multi-use parks, a very large park, but it was a football stadium, an MLB stadium. And he also had designed several New York City bridges, so he really had kind of a strong civil sense to him. It is the third oldest park in major leagues. It's not even close to the first two, actually. Fenway is 1912, Wrigley is 1914. So this is, 50 years later, but still it is the third oldest park. So they're very proud of that fact. Originally, it was built to actually be expanded. So this is kind of the pavilion outside here. It was actually designed to be modular, to be expanded all the way around the end of the park, which was also a feature of Shea Stadium. So this was something that Praeger really kind of built into his designs. Ultimately, they never did that. The thinking at the time was that this was built for forward-thinking expansion, thinking that we need to have more and more seats. In fact, the trend has gone the other way. The features, because this was built in a large open field, it's extremely symmetrical. This is also something that's very closely guarded by the Dodgers. If they're going to do something in right field, they're going to want to do something in left field to equalize this. That kind of drives the architects crazy because they don't always like symmetry like that, but that's something they do guard closely. The other thing you'll notice is the kind of the ubiquitous use of the Chevron shape. This has kind of become sort of this iconic shape of Dodger Stadium, and it's kind of apropos to our setting here. It's a little bit like hidden Mickeys around the park. If you look hard enough, you'll see a lot of chevron shapes just kind of hidden in the backgrounds. And I myself have had the honor of actually working on this stadium for probably the last 20 years. It was one of my first projects coming out of school, designing some netting, backstop around the back, and I've continued to work on this through my various firms and have enjoyed actually doing some very, very significant work in the last 10, 15 years with Nabin Associates. So why concrete, actually? Mr. O'Malley simply wanted it to be concrete. It was just kind of a mandated approach. So fine, they adopted the concrete. At the very basic core of it, it is just a concrete frame building, and it's carved into this hillside. You can see the very steep nature of the actual carving of this hillside. This is all bedrock. This comes into play a lot when we deal with how to renovate the stadium and how to find new spaces for the stadium and how to kind of capture spaces back in this back void area. To save weight, this whole building is actually lightweight concrete. So in fact, even though it's about 120 feet tall, their footings are 12 feet wide, 14 feet wide. It's just a much lighter concrete structure building than you might expect. And I'd also say that for my own personal view, the drawings that they put together for this building are just, they're beautiful. They're hand-drawn, of course. Just the meticulous detailing and the specifics of every nook and cranny. You just don't see this kind of drawing anymore. It's really a piece of art. So why, and if you're familiar with Dodger Stadium, why is it called Chavez Ravine? It's actually sitting on a plateau on top of a hill. So why do we call it a ravine? It's actually, in fact, built over top of two ravines that were filled in during the construction of the Harbor Freeway. There's up to about 120 feet of fill that's just filling in these two ravines. It's a little bit of the checkered past of the Dodger Stadium site, not necessarily related to the Dodgers, but as they were filling this in, they had to relocate some communities up there. Originally, this whole site was actually earmarked for low-income housing, high-density low-income housing, but the change in the political environment actually shifted that out of this area, and it went into, this became the public venue of this Dodger Stadium. So the result of that, frankly, is that as they shaved the top of the hillsides off and filled in the canyons, half of the stadium, in fact, is on very deep fill, the other half on very stable bedrock. And that's why you saw this very steep kind of hillside construction. That actually is on the bedrock side. But if you go to the fill side, you have very shallow construction processes there. And this is where you start to see the civil engineering them come through. They actually took section cuts at every key section of the building and created grading diagrams. Grading plans, grading sections with points of grading. You just don't see that kind of detailing anymore. And this was actually part of the structural drawings, which is pretty amazing. So how do you actually build this? It was actually a precast, site-cast, precast concrete structure. A very progressive design. This is kind of the placement drawing. It was a bit of a jigsaw puzzle. Essentially creating these large pieces here that they would site cast and then lift into place and then connect with precast planks and then infill with a structural concrete that really bonded the whole system together, creating an emulative construction. They were really kind of trying to get to a cast-in-place concrete construction method with this precast version. It proved to be a very effective process, and they had lots of land to actually site cast this. But the level of detail of how to put this jigsaw puzzle together was pretty astounding. There's over 23,000 precast units, about 40,000 cubic yards of concrete in this building. But they really kind of had to struggle with, how do we effectively put this together in a very efficient way. So they issued, in fact, one of my favorite drawings in the whole drawing package, this whole series of crane placement diagrams. I'm just in love with this particular drawing because the level of detail that they took this is astounding. They're actually just showing the sequence of these gantry cranes and how to place them piece by piece to be the most efficient construction procedure. They have a little note here that says this is a possible erection procedure, but you know they hope they were going to do it this way. But I think partly they're also just kind of showing off here. This is, and this is the bridge engineer in them coming through. So the early grading and construction, you can see as they're starting to grade this whole thing, as they're just carving it into the hillside. Again, this is the bedrock, very steep side. This is the fill side over here. You can see they actually did use the crane idea, but they actually have it on this rail system so they could maintain specific alignments. So it was all very meticulously done in a very large-scale way. Picture of Walter O'Malley, kind of the proud owner, as he's kind of looking over the casting yard, if you will. You can kind of see these stacked precast units looking very deep, but in fact it's 2 units because there's identical units on each side of the stadium. This symmetry was very important to them. A very 1950s photo with the Walter O'Malley pointing with his cigar, to the press guy giving his press conference, just kind of showing, the construction of the stadium. It's kind of a fun picture. And the completed stadium in 1962. The other thing that they were very cognizant of was the idea of the automobile. I mean, this is Los Angeles, so it's in fact, that is kind of the indelible icon of LA even at that point. You can see the massive amount of land that is up at Chavez Ravine. And the logic of how they were getting people around the stadium is very evident. There's a lot of ring roads. There's in fact 6 primary exits, so it's actually really fast to get in and get out. Despite the fact that there's 50-some thousand people, you actually can get in and out pretty quickly. You can also see another fundamental aspect of the design, which was they really wanted the patron or the fan to park on the same level that they were going to be sitting. So you can see this very tiered kind of parking lot structure to it. So if you were parked up here, you were coming into the top deck. The result of that actually is that there's not a lot of vertical circulation in the stadium. It's actually hard to get from one level to the next, which has actually proved to be one of the challenges of the current ownership, to maintain relevance in the modern world of concessions and points of sale. That there's some levels that have wide concourses that it's very amenable to that. There's other levels that don't. And how do we get the patrons up and down this? So this is still something that we continue to try to improve on. But the logic of how they laid it out was very clear. So the seismic design, being a structural engineer, I'm always very interested in this. It's actually comprised of 5 distinct sections, 5 different buildings highlighted here. It's fundamentally in this circumferential direction, a shear wall system with the shear walls kind of straddling right up into the joint. These joints are up to about 14 inches wide. So again, it's a very forward progressive thinking design. In the 1950s, they were trying to anticipate movements of the upper joints. 14 inches sounds like a lot, but in fact, 120 feet tall, that's only about a 0.5% drift each side. So it actually was something we had to address eventually. In the radial directions, it's basically all moment frames. The entire precast frame is just one moment frame. So it was a very robust and very redundant design. Again, I would say very forward thinking. The concrete is very robust. It's got lots of confinement. It's got high strength steel in it. And the concrete has fared very well. The strength is very good. So perhaps the first really renovation project or preservation project that they undertook in a major way was addressing the seismic concern, a real structural basic concern of the stadium itself, maintaining the relevance of the stadium and its own structural stability. So about 2000, 1997, 1998, 2000, we launched into a very aggressive full structural seismic upgrade. This was just shortly after the Northridge earthquake. So they were very keen on this idea of addressing this issue. So we used the newly published FEMA documents as far as retrofitting existing buildings. These are still very much in practice today. They just had some evolutions to it. So it maintains its relevance that way. We added some shear walls along the circumferential direction in places we could kind of hide them. We actually added a whole bunch of shear walls in the radial directions to actually relieve the entire moment frame from its active duty as the seismic resisting system. That opened the door, frankly, for the Dodgers. What that allowed them to do is now unburden all the columns with seismic forces, and then we could just use them for the gravity forces, which opened up a world of opportunity for them to expand. in ways that they needed. This is what it looks like when you look at the section view. They basically kind of filled in and connected the stadium to the hillside. You can see some very, very tall walls. This is basically void space between the stadium and the hillside. Connected it up with grade beams and basically pinned it all against the hillside. Also fiber wrapped the canopy at the top because we know the top shakes a lot of acceleration up there. But what this allowed, frankly, was now they could start to push into the void space and they could find this additional space. And this was the real catalyst for the first kind of expansion of the stadium, which wasn't forward, it was actually backwards. They weren't trying to add more seats. They actually were thinking they maybe had too many seats because they couldn't have enough amenities to serve all those people. So they actually were thinking maybe a little less seats, but much more amenities. And where do you serve the amenities? It's all back of house. So the first real push was go into the big void. And so we basically just filled a bunch of this void with back of house space. It was mechanical, it was food service, it was concessions, it was new mechanical, electrical, plumbing. All of this stuff now found a new home. So that was the first big advancement that they had. And you can see kind of the result of all the work prior to the new. The character's largely the same. It's just now they've added all the amenity fan-based things around the outside. Again, preserving that modern features. Get another view. You can see they actually restored the scoreboards. They kind of went through this period of rectangular. They restored them, of course, in a chevron shape and, of course, in a symmetrical way so that they can maintain that. Janet Marie always likes this slide to kind of highlight the idea that the original design, in a very subtle way, in a very architectural way, the early morning and afternoon, the sunlight really kind of glows on this upper canopy, and she loved that idea. So in fact, one of the ways to celebrate the original architecture was actually put lights up there. So at night, you actually feel like it's doing the same thing. It's trying to get the sense of lightness of the stadium. So these are kind of the subtle ways that they're doing to try to maintain that original architectural vision. But they still needed more space. So this was the back of house space, so the seismic, and now they actually have to address the players, those poor neglected players. They had not ever actually done any upgrade for the players since the 60s, essentially. So the clubhouse was the same, but they needed the clubhouse. Where do they put it? They didn't know where to find the space. Well, they finally discovered, well, maybe we'll put it underneath all of the field level seats. As a precast construction idea, we would say, well, I'll do it in precast again. It'd be very fast, very quick. But in fact, we didn't have enough time to actually do the fabrication drawings for the precast, so we elected to go cast in place for that. It actually gave us some flexibility to adjust to changing programmatic requirements. That's code word for the owner changes their mind. And where we could also adjust to field conditions that frankly weren't exactly as we anticipated. So they had to do all this in 4 months. They ripped out the entire field seats, demoed it all out, shored it up. This was probably like a month later. You can tell this is the middle of winter because some of the guys have their really warm t-shirts on. This is Los Angeles winter. So through this period, they had about well over 100 permits to try to pull all this stuff together. Because at the same time they were doing concessions at the top, they were doing outfield concessions, kind of bringing the whole outfield experience back into the park. This is the finished clubhouse. Again, this is establishing relevance of today's players so you can attract the best talents. Now they have one of the nicest clubhouses in the major leagues with just the most modern and up-to-date amenities. This is the weight room that's actually under the seating slab. They added some bullpen bars. You can see the hidden Mickey right here. There's our Chevron Shape that's actually functioning as a bar. So they'll find any ways they can to do that. They regraded the entire outfield to try to bring that fan experience. And really the idea was that they're trying to connect all of these people from the pavilions to the main stadium, which had never been there before. So they're finally able to connect this all up. They added concessions up on the upper levels, on the 7th level. Again, bringing that modern amenity feel to an old ballpark, because this is what all the new ballparks are doing. It's all about point of sale, concessions, and getting people moving around. This looks like a simple enough building. I'll tell you in a second why it wasn't. Here's the little concession and add a little park. So that building that we were looking at, the reason why these aren't very easy to do is, in fact, that building is actually on 3 different buildings because it's straddling on grade, it's on the structure, and it's actually straddling a seismic joint. So that little tiny building, we actually had to slice it into 3 pieces. So that was sort of the challenges you have to work through. This is a this is a result of the bedrock versus fill issue. And because of that, they didn't actually do this on the right filled side. This is one of the few times that it's not done symmetrically. Also, this little guy here, they couldn't get under here to actually shore up there to do the beam work to strengthen to hold this building. So in fact, we said, okay, well, let's just use the concession counter as a grade beam and just span it to the columns and just sit it on the stadium. Again, we could do that because now these columns don't have to take any seismic loads, so we had a lot of reserve capacity. And some fun things, you know, certainly you always have to keep the fans interested, the younger fans, just the bobbleheads, even these needed some engineering, but these are a fan favorite. And then probably one of our favorite is the giant, what I call wrecking ball baseballs. These are concrete, just cast concrete, and it's kind of one of Janet Marie's favorite stories in how we were doing this, is they commissioned these balls. These are 54 inches, and originally they just wanted to be able to pick them up and put them anywhere they wanted to at any point in time. And they had like this little, they were just going to shave a little 8-inch piece off the bottom so it could just kind of sit nice. You guys are crazy. You're going to put a 3.5-ton wrecking ball on the top of a mountain, and when the first earthquake happens, it's going to land in downtown. So eventually I talked them into getting this little stand. They capitulated, they went ahead and put it in there, and now Janet Marie makes fun of me mercilessly about it. But I sleep better. So thank you.